In this video, we'll see construction of Galois field 2 raised to 3 with a primitive polynomial x cube plus x square plus 1. So, the important points are alpha is the root of this primitive polynomial, and every field element of Galois field 2 raised to 3 can be expressed as powers of alpha. Alpha is primitive element. So, the elements of Galois field 2 raised to 3 will be 0, 1, alpha, alpha square, alpha cube, alpha raised to 4, 5, and 6. If you count it, it will be 8. So, the root of this primitive polynomial x cube plus x square plus 1 is alpha. So, first we will put that alpha in x cube plus x square plus 1. So that will be alpha square plus alpha plus 1. So that is equal to 0 because alpha is the root of this primitive polynomial. So alpha cube is equal to minus alpha square minus 1, but minus equal to plus for Galois field 2. So alpha cube is equal to alpha square plus 1. So next we will find alpha raised to 4. Alpha raised to 4 is alpha cube into alpha, that is equal to what is alpha cube? Alpha cube is equal to alpha square plus 1. So alpha square plus 1 into alpha, that is equal to alpha cube in plus alpha. Alpha cube plus alpha. Alpha cube is alpha square plus 1. This alpha. So that will be alpha square plus alpha plus 1. What is alpha raised to 5? That is equal to alpha square alpha raised to 4 into alpha. What is alpha raised to 4? That is equal to alpha square plus alpha plus 1 into alpha. That will be alpha cube plus alpha square plus alpha. What is alpha cube? Alpha square plus 1. Then alpha square plus alpha. Alpha square gets cancelled out because 1 plus 1 equal to 0. So alpha square plus alpha square is equal to 0. So remaining is 1 plus alpha, that is alpha plus 1. Then alpha raised to 6 is alpha raised to 5 into alpha. So what is alpha raised to 5? That is alpha plus 1. So alpha plus 1 into alpha, that is equal to alpha square plus alpha. So the field elements of Galois field 2 raised to 3, which is obtained with the primitive polynomial x cube plus x square plus 1, and its base field is Galois field 2. So this is the power representation of the elements which are expressed as the powers of primitive element, and this is the polynomial representation of the elements which are obtained by the modulo primitive polynomial operation. This whatever we are doing, alpha raised to 4 is equal to alpha cube plus alpha, then we are obtaining alpha square plus 1. That is nothing but mod primitive polynomial operations, but we will not go in that detail because then it will be lengthy video as well. That is not needed in your exam to compute like that. So computing like this will also be okay.